Hello everyone and welcome back to a new video. So just yesterday, Mistral have launched their new OCR model and they're claiming that it is the best model on the scene. And in this blog post that they've just published yesterday, we can find many demos showcasing the capabilities of this new OCR model. So as you can see in this demo video, the model can understand and extract complex document elements. So it can extract text mixed with images, tables, and also mathematical expressions. And it is also noted that it can handle advanced layouts, such as LaTeX formatting. So I wanted to put it to the test and see if it is actually as good as they claim it to be. Alright, so without further ado, let's get right into it. Alright, so here we have the notebook. Now the first thing I would recommend to do is to go to this secrets vault and save your Mistral API key here. And then you can give your notebook access by using this toggle button. And you can use this code to use your API anywhere in your notebook. Alright, so the first thing then we need to install the Mistral AI library. So let me go ahead and run that. Then we need to import a few libraries that we're going to work with. And next we need to set up our Mistral client. So we pass our Mistral API key and we create our client. Alright, so we will start first with the image OCR, and then we have file or PDF file OCR. We're going to test that later. So first, to test the image OCR capability, we need to import few images. So here I've prepared few testing images that we're going to use. Okay, so let me show you what we're going to work with. We have good quality course notes, and as you can see we have two-column page with many math equations. Then we have low quality course note. Let me open it. And as you can see here we have low luminosity. Also, as you can see, we have noise in the background and the writing style is way worse than the other one. So this is the low quality course note. Then we have a hard cheat sheet, and this is a hard one for OCR models. As you can see, we have many columns and rows, and we have even vertical texts, and we will see how the model would perform on this image. And finally, we have a small prescription. So usually I use images for prescriptions to see how the model would perform on very poor handwriting style. Alright, so let me close the preview. So we will start first with the good quality course note. Let me run this. Now I've prepared here a preprocess image function. Now usually when we pass an image to an OCR model or engine, we need to preprocess it first to make the model perform better. So what we mean by preprocessing, let me show you. So if I reopen the preview for the good quality, you can see here the original image. And then when I run these cells, here you can see the preprocessed image. And as you can see here we have only black and white, and we have high contrast. So these transformations that we applied from Gaussian blur to thresholding and then erosion and dilation would give us a suitable image for OCR models, and we will see how this preprocessing step would impact the performance of the Mistral OCR. Alright, so let me close the preview again. Next we have the encode image function. Now this function takes the image path and then parameter on whether to preprocess the image or not. And the function would return the encoded image in a base64 format. And this is the format that can be used with the OCR client from Mistral. So it requires a base64 encoding for images. And then I've added here the case where we apply preprocessing. So the code for the encoding function and the code on how to call the API server, you can find them, of course, on the Mistral AI documentation. Alright, so let me run this cell. Then we encode our image, and let's first set preprocess to false. Next we perform the OCR using our client and we pass the base64 image. So let me run this cell and print the response. So here we have the response object. It contains a list of pages where in each page we have OCR page object, which include the index and the markdown. So this is actually the extracted text from the page or from the image. And then, as you can see here, we have images where the model store the extracted images. But here, as you can see in image base 64, we have none. So the model wasn't able to extract the image correctly. Then we can print the extracted text using the display markdown functions. Alright, so let me go here. First we have linear algebra. Let me show you the original image. So we have linear algebra as the title. Then we have properties of determinant. Alright, so they have few equations. We have few mistakes here and there. So here, for example, we don't have an absolute value, we have some kind of square brackets. Then we have everything correct in here. And maybe we have few mistakes in this part. Then in this properties of rank, you can see that it extracted the letter F as a Greek letter, but that's not a big issue. So here we have a system of linear equations. It should be the image of this system of linear equation chart or diagram, but it wasn't able to extract it. Then we have the second column. So we have the eigenvalues and eigenvectors. And I would say it did a really good job extracting the text from this image. And as you can see, it converted all the equations and matrices into LaTeX format. That's really cool. Alright, so let's change the preprocessing parameter and see the result. So here, let me set it to true. And then we run again. Alright, so as you can see, when we used preprocessing, it treated the whole image as one image, and even it wasn't able to return that image. So we have a non-image returned. So as you can see, performing preprocessing wouldn't work as well as I thought it would. Alright, so we'll keep that in mind. Now let's try another image, for example the low quality. We'll copy the path. So this is the preprocessed image and here the original one. Let's run the OCR model. Alright, so with preprocessing again, we didn't get any results. Let's set it to false. And we've got the result now. So let us see. Here we have regularization instead of regularization, linear regression and logistic regression. So as you can see, we have few typos here and there. Again, we have regultangation or whatever this word is. Techniques are used to deal with overfitting problem. Alright, so then the image again, it didn't extract this image. And it extracted this equation but with the wrong letters. So we have the correct format but with different variables. And at the end we have, however, having too many features is a well-known cause for overfitting. Having too many noise level, data robustness of the size and the training data itself. I thought it would perform better on this image specifically, but maybe because of the poor handwriting and the low luminosity it wasn't able to get it right. Alright, so let's move on to the next image. Now we have this cheat sheet paper. Let's run it again. So as you can see here, the preprocessed one. We're not going to use preprocess this time. And let's see the result. Well, it didn't return any text. Let's try with preprocessing. Again, it couldn't extract the text in this image. maybe because the size of the text is too small and it is very crowded, so it treated it as a whole image. But then again, we didn't get any image returned from the API. Let's try with the last example. So here we have the prescription. And let's set preprocess to false. Alright, so we have a result here, name Anamail Siga, and the actual name is Armando Coquilla, and then we have the address West Rambo, which is correct, and then we have Makati City, so here we have Mabati City, so we have typos. And as for this part, we have amoxicillin 500 milligrams, but here we have Sormi Cap 4. I say it did a pretty decent job extracting the text from this prescription, given that even the human level accuracy is low on this kind of writing style. So for the 4 examples that we used, the best performance was on this good quality course note, and then we have lower performance on the low quality, and then it didn't do anything on the cheat sheet, and it did a pretty decent job on the prescription. I think maybe the reason for that is that the model was trained more on papers and structured documents with clean writing or even typed documents. So that's why it performed better on the first one. And to verify that, let's use the file OCR. So let me close the preview. So using this file OCR, we can upload a PDF file and then use the API to extract all the text from the PDF. So let me upload first the PDFs I prepared. So let me show you first the PDFs that we're gonna use. We have the demo PDF. So this is the paper for Mistral 12 billion, and this was used in the demo on the blog. As you can remember, we've seen how this was converted to Markdown. Then I've chosen another paper that I want to try it on. So we have the dataset distillation paper, and we will see how it performs extracting the algorithms, the images, and the equations, as well as the text. And finally, we have this MIT lecture notes. So this is from the MIT website, and you can see it's handwriting for course notes. Alright, so let's start first with the demo paper. Copy path, and we're gonna put the path in here. So we will use the client files upload to upload the PDF, and we set the purpose to OCR. Then we can retrieve the file using the ID to verify that it was uploaded correctly, and after that we create a signed URL. Now this signed URL is used to pass the document to the Mistral OCR model so that it can perform OCR. So now let's run the OCR and print out the pages. Alright, let's go up a little bit. So here we have the Mistral 12 billion. Let me show you here. So we have the Mistral, then we have an image. And as you can see, it didn't extract the image correctly. It knows that here should go the image, but the data for the image was not retrieved. So then we have the introduction as well as the links. Alright. Then we have a few graphs, and there should be image here, yes. And then we have this segment, and we have this table for multimodal decoder. Let's check that. So this is the table. So it actually extracted the table correctly, as you can see. And that's a really good job. So it is not exactly as was shown in the blog post. For some reason, the images were not extracted correctly, but the overall performance is really good. So let's move on to the next PDF. We will try the dataset distillation. Copy path. And let's run it. Now this is a long paper, so it should take a little bit of time. We have 14 pages. Alright, and now we have the response. Let's go up. Alright, we have the distillation paper, the introduction, the related work, approaches with the equation. That's really good. That's a really good job. Now again, we won't expect any images, but the tables and all the equations with the correct text. So I guess the best use case for this model is on typed documents, and we will try the last PDF we have. So we have this one, we copy the path, and let's run it. Oh, I made a mistake. We need to paste it over here. Let's run it again. Alright, so let me see. So here we have course, lecture note 6.334, load regulation review, lecture note, land regulation review. So again, with the handwriting, there are a few typos with the text. Then we have the equations. For example, VL L dTc over dt equals 0. There are also a few mistakes within the equation extraction. And then here we have some kind of a table. So as you can see, when the structure of the document isn't well organized or isn't typed, the model struggles to perform well and extract all the components correctly. And that's really my observation on this model. This model is very good on typed and structured text, but it struggles a lot with other kind of text or other kind of format. And we've seen its performance with handwriting in both images and PDFs. Now I've tried these examples with other OCR models and other OCR engines, and they fail miserably in extracting the handwriting. So I think this is a huge improvement in the OCR field. And even though I don't think the reported accuracy is reflective of the real performance of the model on many use cases, I really think it's a pretty good model, and maybe the model you should use if you're trying to perform OCR on structured or typed documents. Alright, so that's it for this video, and see you in the next one.